For the first mile or for subsequent miles? Oh, oh, right, because it'd be 4 laps, right? Okay, that's pretty impressive. Uh, okay, so let's pick up where we left off last time. Um, and I wanted to point out a couple of minor changes that I made to one thing. Okay, so there's now a page here, and it's linked from one of the assignments, but you can also get to it by just going to pages. Okay, and it's called Turing machines. And right now there's only one Turing machine in it, but we're going to create another one today by kind of thinking it through. And so we'll end up putting it here. And in fact, I'm going to turn on editability for this, or actually I'll make a second one that's editable. So just ignore them. Um, the maybe they'll get the hint. Uh, I'll make a second one that will be editable by you guys. So okay. All right. So the one change I made to this. So this is basically the chart out of the book. So it's just slightly formatted differently because, of course, I typed it. It's not in the book. But the change I made is to use X, just the letter X instead of the star. Okay, and I'll explain why I made that change in a moment. Does it really make any practical difference for us as humans? No, right? It's just a symbol. Okay. Um, and right, so I made that change for a reason, and then I made some, formatted this thing. Okay, and the reason then that I used X for the in place of the star is to be able to use the star as sort of a wild card. Okay, so wild card means like it could be any symbol. So star would represent here that it could be an X, it could be a 1, it could be a 0. Um, and it doesn't matter what symbol it is. Okay. And then if I put a star here in the symbol to right, that means just don't change the symbol that's there. Okay. So whatever was printed before is now the new symbol to be printed again. Okay. That's really just shorthand because I could um, just have 3 rows here for overflow, the case where it reads a 0, the case where it reads a 1, and the case where it reads an X. And so really this is just shorthand. It's not a substantive change to the idea of the Turing machine. Okay. The other thing that I did this for is because there's a very nice little simulator that I found. Okay. And I had forgotten to mention this yesterday. So let me copy this piece of code. And let me go to this website. Okay, here's how you use it. So the first thing I'm going to do is, well, once it loads, it's going to take a second. Is I'm going to just paste in this code, and essentially this code is just a it's basically just the table, right? But sort of in a coded form. Okay. Then over here on initial input, I'm going to put uh, this string, which is what we used last time for our when we executed this by hand. Okay. Now the other thing I'm going to do is hit advanced options and say that what state do we start in? We start in the state start. Then I'm going to hit reset, and that will kind of load everything into the simulator. Okay, so the star here in my initial input, or where it basically the initial input is, well, what does the tape look like before I start running the machine? Okay, and that's what the tape looked like, right? We had a 101 in between some X's or stars, whatever. Okay, good, got that? All right, so the notice in the initial input box, what did I type? I had X101 star X. So what does the star indicate in the in a tape input or a tape state list? Yeah, where the head is. Okay, and so now here's the annoying thing, right? Really, the head is over the X, but I can't put a star over an X when I'm typing it, right? So the convention that whoever wrote this thing did is, okay, I'll just put the star immediately to the left of the symbol that the head is over. Okay, he could have done it immediately to the right. It doesn't really matter, but you had to pick something. Okay, so that's how I can tell the machine that I want the head to start in a particular location. Um, and the way he wrote it was that if you don't specify that, the tapes or the head starts on the left hand end, whereas what did we kind of assume last time? That we started on the right. Again, it doesn't really matter, right? They're equivalent basically, but once you pick a convention, you have to stick with it. Okay. So because we started with the convention of always starting with the tape on the right, um, and he chose it differently, well, let's just modify our convention to always explicitly stay where the head starts, by putting that asterisk in our tape configurations. Okay, make sense? All right. Now, as for the code here, if you will, right? Really, this is just our table. Okay, and so for example, what was the start in the table? The start state: if you see an X, you print an X, you move left, and then you enter the state add. Okay, is how you read this. Okay, and then if we go down to, say, for example, the overflow case, if you are in the case overflow and you read anything, that's what the star's standing for, you print an X, you move right, and you enter the return state. Okay, and then the rest of them are all uh, just obvious, right? There's no funny business there. Okay, so that's just, like I said, essentially just the table, but encoded into the syntax that this guy made it, and everything is separated then by spaces. Okay, the other one kind of cool thing that he did here is he added one extra symbol, which is if I put an exclamation mark, okay, then at the end of a line, then what it'll do is if the machine gets to that line of the table, it'll pause. So it's not really halting execution, it's just pausing the simulator. We call these breakpoints. And when you're programming, like let's say that you're really trying to concentrate on a certain part of your code and you know that these 500 lines before it are doing fine, right? Well, then what you can do is add a breakpoint at the part that you're actually interested in, and then go through that part step by step, but let the 500 instructions or whatever that happened before just all sort of happen in one swell swoop, so that you can concentrate on stepping step by step at that breakpoint. And of course, you can have as many breakpoints as you want, up to essentially a breakpoint at every line, which is where you're just stepping through line by line the instructions. Okay, so does that make sense? Yeah. Okay. The then here with the execution, right, is I can step through one at a time, right, or I could just hit run. All right. So if I hit run, it'll run pretty quickly. Okay. And was this the configuration that we got at the end of when we were doing this by hand last time? It ought to be. Okay. And great, it worked. And it should have taken 5 steps. Does that jive with what we had when we did this on by hand? I think. Yeah. Okay. Well, good. It should, right? And we can see here the finished configuration of the head or of the tape, in which case, how would we write this down? X110X star, right? Because where is the star or where is the head? It's to the right of the X, okay, meaning it's above the symbol immediately to the right of the X. Okay, does that make sense? Okay. Um, yes, um, or we could actually make a letter to represent a blank, like an underscore or something, for example. Um, yeah. So, and in this case, right, did we really have to move right when we halted? No, strictly speaking, we didn't. And in fact, I'm not sure if it actually does this if you have to move. Let's try that actually. Yeah. Okay. So we can use star to mean don't move, in which case the starting or the ending configuration is here. Um, I'll just go ahead and put it back the way I had it because um, that's consistent with the um, the table, right? Is that I put a right there, so that way we're just consistent. Yes.
In the book, that last step was don't move.
Oh, it was.
Yes.
Okay. Well, in that case, I'll edit it. And so let me edit that now because I want to be consistent. Um, this also means I'm going to have to go in and change one part of one assignment because I think I assumed that it was that. Okay, so we'll update that, and then we'll go down to here. We'll change that to star. Okay, and then we can change that here to star. Okay. Oops, don't do that. Okay, so now if we reset and rerun it, same result basically. It's just that we end on top of the X instead of the to the right of it. Doesn't really matter. Okay, so what would our with this convention then? What would our uh, statement be about like what's the final configuration of the tape? X10 star X to indicate that the head is above the right hand X when execution is finished. Okay, does that make sense? Okay, so slight different convention from last time, but not dramatically different. Okay, the only other thing about this simulator that I want you guys to know about is, well, he has some example programs that are kind of cool, but you can also save your stuff really easily. So if you hit save to the cloud, what it will generate is a URL, and all of this stuff is basically just an encoded version of your machine and all your settings, right? So if I copy in this link, and let me just open it, say in a new window, right? It's going to load that in, and well, okay, I should have reset it first, but all right, so if I reset first, um, and then hit save to the cloud, let's try it that way, and then go to it, then we have the machine in loaded configuration from the get-go, okay? And therefore can run it. So this will be very useful because for one of the assignments, you guys will be creating a Turing machine or two, and all you have to do is do it in this. You can check and make sure it runs correctly. And then how would you turn it in? All you got to do is give me that link, right? So that will accelerate the sort of bookkeeping aspects of this. Okay, okay, and you can hit the run button or you can hit the step button and sort of step by step and see, okay, what state is it in, what state was it in, what state it's about to go to, and so on, and then reset and go back to the beginning. Okay, um, and like I said, he's got some nice examples, and uh, so for example, binary addition, right? How to add two numbers. Now, this is where Turing machines, as you can see, get a little complicated, right? Um, and oops, what we're going to kind of look at is, um, uh, in some sense, this is Turing machines are impractical for actually doing computations, right? There are better ways to kind of think about writing code. But what we'll do is we'll sort of show that every sort of primitive element of code that we could write that doesn't look as sort of nitty gritty as this Turing machine thing, every single little snippet of code that we could write, like conditionals and looping expressions, can be expressed in terms of a Turing machine. Okay, and if we can do so, then what we've shown is that our language is essentially what's called Turing complete, meaning it can be implemented by a Turing machine. And Turing complete means that uh, the language is as full featured as it could possibly get, right? Meaning that anything that's calculable, your language can do. It might be a real pain in the butt to to implement it, but it theoretically can do anything that's calculable. Okay. And so this also means then that we can sort of translate between higher level looking stuff that's more practical to work with and Turing machine stuff, which is more theoretically useful. Okay. Does that kind of make sense? Yeah. So that's sort of the idea. Um, okay. So, um, yeah, Gucci. Um, so let's make some Turing machines. Okay. What was the Turing machine that we've done so far? Yeah, it added one. It wasn't addition of two numbers, okay? It just took a given number and added one to it. That's
So
it.
it's sequence.
Yeah, it's a successor function is what we call this, okay? But we could do other Turing machines, right? So, for example, yeah, what about a subtraction Turing machine? Like if I can increment a number by one, could I decrement a number by one? Yeah. Okay. So let's figure out what or an implementation of that Turing machine today. Okay. And for this, I'd like us to kind of get a little bit our hands dirty. We got plenty of room at the chalkboards. I'll raise one of the screens so that we've got a little bit more chalkboard, and I'll quit the stream here. And then once we've got it all put together, we can put it on the a Turing machine page on Canvas. Okay, make sense? All right. So I'll quit the stream and then we can get to it. Oops.